Okay, welcome to today's lesson. In this video, we'll continue with a series of lessons on the IUPAC nomenclature of organic compounds. And here, basically, we're going to look at the rules again, guiding IUPAC nomenclature of organic compounds, right? Here are the rules. So here are the rules guiding the IUPAC nomenclature of organic compounds. The first rule is to identify the longest continuous carbon chain, right? You identify the longest continuous carbon chain. Secondly, you number the carbon atoms in the main chain. You number the carbon atoms in the main chain, you start numbering from the side nearest the functional group. And then the third thing that you do is to identify the name, substituents, and assign numbers to each. You identify and name the substituents, and then you assign number to each. Then the fourth rule is to arrange the substituents alphabetically and then add suffix for functional group. Then here is the order of priority of the functional group. We have carboxylic acid comes first before esters. Esters has more priority than aldehyde. Aldehyde have more priority than ketones. Ketones, you have alcohol. From alcohol, you have amines. From amines, you have alkenes. You have the alkynes and then the alkenes, right? So this is the order of priority of the functional group. So the most powerful here is the carboxylic acid, right? The carboxylic acid followed by the esters, followed by the aldehyde, ketones, alcohol, amines, alkenes, alkyne, and then the alkene. So let's look at this example. What is the IUPAC nomenclature of this compound, of this organic compound? So the first thing that you should do, the first rule is to identify the longest continuous carbon chain, right? So this is the longest continuous carbon chain. Then the next thing is to number the carbon atoms in the main chain. That is, in that longest continuous carbon chain, start numbering from the side nearest the functional group, right? So let's number this continuous carbon chain, the longest continuous carbon chain, starting from the side nearest the functional group. So what is the functional group in this organic compound? The functional group is the double bond. Is the double bond. So where do we start the numbering from? We start numbering from the side nearest the functional group. If we start numbering from here, here will be 1, 2, 3, right? So the functional group will be at position 3. Then if we start numbering from here, it will be 1, 2. The functional group will be at what? At position 2. So therefore, the correct number would be from this side. So this is the first carbon, 1, 2, 3, 4, 5, right? So this is the longest continuous carbon chain. What does that tell you? That this compound is a pentane. It's a pentene, so to say. It's a pentene because it has what? The functional group is what? A double bond. So this compound is a pentene. Pentene. Pen is for 5. In means that it has double bond, right? So this is a pentene. But this is not the IUPAC nomenclature. The next thing that you should do is to identify and name the substituents and assign number to each. So there is no substituent, arrange the substituents alphabetically, no substituent, they add suffix for the functional group. So we've already added the suffix for the functional group. It is what? A pentene. So what position is the double bond? 1, 2. So it's at position 2, right? So therefore, the IUPAC nomenclature of this compound is pent, give a dash, 2, give a dash, in. So that tells you that the pentene is at position what? 2, is in the second carbon atom in this pentene chain, right? So this is the IUPAC nomenclature of this compound, pent 2 in, pent 2 in. So let's look at this other example that we have here. What is the IUPAC nomenclature of this compound? So the first thing that you want to do is to identify the longest continuous carbon chain. That's the first rule, right? Identify the longest continuous carbon chain. So what is the longest continuous carbon chain here? Obviously, is this 1, 2, 3, 4, 5, 6. So this is the longest continuous carbon chain, right? Then the next thing is to number the carbon atoms in the main chain starting from the side nearest the functional group. So the functional group here is an alkane, is a single bond. The functional group is a single bond, right? Single bond. So this is an alkane. Then the second rule, like I said, is to number the longest continuous carbon chain starting from the side nearest the functional group. So like I said, the functional group is what? The single bond. Then the next thing is to identify and name the substituents. Is to identify and name the substituents. So what we basically have here is a lot of substituents, right? So identify and name the substituents, right? So I'm going to start numbering from the side where I will have the lowest number attached to the substituents, right? If I start numbering from here, it will be 1, 2, 3, right? So that means this methyl group will be at position 3. This chloro group will be at position 4. This methyl group will be at position 5. But if I start numbering from here, this will be at position 2, this will be at position 3, and this will be at position 4. So where we have the lowest number assigned to them is from this side, right? So I'll start numbering from here. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6, right? So we've identified the longest continuous carbon chain, and we started numbering from the side where we'll have the lowest number attached assigned to the substituents, right? Then the next thing is to identify and name the substituents and assign number to each, right? So the substituents that you have here, we have a methyl group at position 2. So this is the substituents are the substituents. The substituents are we have a methyl group at position 2. So that's 2 methyl, right? This is one of the substituents that we have. We have a chloro group, chlorine. This is chlorine, right? So it's a chloro group at position 3. So this is 3 chloro, right? Then we have a methyl group again at position 4. So that is 4 methyl, right? So that's 4 methyl. So this compound, the parent compound is what? 1, 2, 3, 4, 5, 6. The parent compound is a hexane, 6 carbon atom. So the parent compound is what? Hexane. 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 So what is the IUPAC nomenclature of this compound? So the IUPAC nomenclature of this compound would be, if we go back to the law, identify and name the substituents and assign numbers to each. We've done that already. And then arrange the substituents alphabetically. So we arrange the substituents alphabetically. This is very important. So arranging the substituents alphabetically, chloro comes before methyl, C comes before M, right? In terms of alphabet. So therefore, the name of this compound is 3 dash chloro 3 chloro dash 2 4 this 2 this 4 dimethyl 2 4 dimethyl. Dimethyl means what? That there are 2 methyl group. 2 methyl group in position 2 and in position 4. So this is 3 chloro 2 4 dimethyl hexane, because the parent compound is what? The hexane. So this is the IUPAC nomenclature of this compound. 3-chloro-2,4-dimethyl-hexane. Very simple and straightforward as well. So in the next video, we'll look at some other compounds and how to write correctly the IUPAC nomenclature.